All right, everybody, here we go. A forester takes measurements in a grove of trees. Naturally, larger diameter trees also have larger volumes. The bigger, so let's say that's represents the thickness of the tree. So the bigger the diameter, the distance straight across through the middle of the tree, um, the more tree you have. Okay, well, that makes sense. So they've got that information cataloged over here. All right. So diameters are over here and the volumes are here. All right. Now you're going to see in this class an awful lot of these T charts. Okay. It's called a T chart because often you just draw a T. Okay. Or it's also called an input output table. Now, whatever information is on the left side, we call that information our X information. Those are our X values, and the stuff on the right, the volume numbers, those are the Y values. So in this problem, diameter is X, volume is Y, and it's just left and right like that every time. Okay, so we're supposed to start off by making a graph of the data large enough to include a 13 centimeter diameter. Okay, notice the diameters that they give us only go up to 10.9. So we need to make sure we go a little bit further, go up to 13. Okay, and in the X direction. Now the Y direction, I don't know. Let's see. So it looks like they're getting bigger, 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 bigger. They just keep getting bigger, and that's it. That makes sense. So if we're going to go all the way up to 13 centimeter diameter, I don't know, we need to go up to maybe 400, 500 cubic meters of volume, maybe. Again, I'm kind of winging it at this point. So it says go out and use some graph paper. It'll be super cool. All right. Let me. I'm not going to do this on graph paper, and that's okay. I hope that doesn't offend you too much. Let's see. Let me go down to here, and we're gonna shrink this thing down so that we can kind of see what's going on. Okay, and so I'm just going to do my best to graph this thing out, and all right. So first we have to draw our axes, X and Y axes. Okay. Let's see. And it's always a good idea to label them. So notice our X axis, that's our diameter. So I'm going to say, diameter or something. And then our Y axis, that's our volume. And so I'll just put V for volume, I guess, and that'll be super cool. And it'd be really great is if I changed up our colors. I want to do a different one. All right. Now, we need to put some tick marks along the X and Y axes in order to, know where we're at. Now, I don't want to do 7.2 on the x-axis and then 7.4 and then 7.5, etc. Instead, I'd rather say, all right, these diameter numbers, boy, I don't know what's up with my throat today. These diameter numbers, they start at 7.2. Let's go, close to that, but a little lower. How about 7? Okay, so let's start at, at 7. And we need to go all the way up to 13. Okay, so 13 is where we're going to be stopping. And that's really cool. Okay. Now, it would be helpful if we had some tick marks in between. Let's see, 7 to 13, that's 6 centimeters. So that means right in the middle is going to be half, 7 plus half of that. That'd be 10 centimeters. And then probably, we could throw in our 8 and our 9, I guess. There's nothing magical about, the exact way I'm selecting these numbers. I'm just trying to get an idea, of where they are so that when I plot this information, it's, makes it easier. All right. Now, what about the volume numbers? Well, they start at 143 and they're probably going to go up to, I don't know, maybe 500. So at 500 is my guess. I hope I'm right. Okay, and so we probably we could start with, I'll just start at 100. How about that? And then that means the 2, 3, 4. Okay, so we need 200 about there, and 300 about there, and 400 about there. And I know it's not perfect, but if you do it on graph paper, it'll be better. And okay, so now it's time to start plotting the points. Okay, so let's see. Let's do. I think it lets me do stands. I'll do these cute little stars here. All right. So the first one is we're going to go in the x direction, 7.2, and then we're going to go up 143. So 7.2 is about, I don't know, about there. And then 143 is not quite halfway to the 200, so maybe about there. Okay. And the next one is 7.4, 157. So I'll go over to 7.4, which is just about 7.5, and then up to 157, and I'm about there. Again, we're not looking for perfection. That'll come later when we do all this on the calculator, which is not in this section. Next is 7.5, 168. So now we are halfway between 7 and 8. And so we're right about there. Okay, and then 7.7, 178. So 7.7 is going to be maybe about there, and then 178 is there. And then 7.8, 189. 7.8, 189. And they're going to start spreading out a whole lot more. Well, maybe not. Okay. And then 8, 199. 8, and that's basically about 200. Okay, and then 8.2, 212. And okay, I'm going to pause this and then do the rest so you don't have to keep watching me do it. Okay. Okay, I've gotten up to 9. You can kind of see how things have changed a little. I'm going to pause again. Okay, and so there's all of the data graphed. No, it's not perfect, but it's pretty good. Again, if we're wanting, if we're doing this for a job, we'd use a computer to, make the graph look a lot better. Okay, so we've got that. Now, let's see. Oh, wait a minute. I am still in graphing mode or whatever. Okay. So let's go to here. All right. So make a graph of the table. Blah, blah, blah. Okay. So part B, find the slope between the smallest and largest diameter trees accurate to 1 decimal place. Okay. I do believe I can do that. Wait, there it is. Okay. Find that slope. So I will, let's go over here on the right. Okay, so the slope between the smallest and the largest. So that's going to be this point there, the smallest, and this point here, the largest. Okay. And so their slope is, well, yeah, okay. So the slope formula is the difference of the y values. So you do the big y value minus the small y value divided by the difference of the x values. Okay. And all the stuff I'm doing in this problem, you're going to get a lot of practice doing this in this homework and throughout the course. Okay. All right. Okay. And so when I plug all that into my calculator, oh, M stands for slope. It's nobody knows why. They suspect it goes back to this French word. It starts with the letter M. It kind of means slope. Okay. So that's going to give us to 1 decimal place 55.7. But again, numbers without units don't really mean much of anything. 55.7 what? Well, we did our volume right there divided by our diameter. Or in other words, we did cubic meters divided by centimeters. So our units are going to be cubic meter per centimeter. How many cubic meters per centimeter? How many cubic meters of volume does the tree increase by for each centimeter that the diameter increases? Okay, so that's the idea, and that's the answer to that next one. All right. to part B. Now, part C says, okay, it's time to draw a trend line. All right, so let me turn on my straight line thing here. So a trend line is just going to be a straight line that best matches the pattern of the points. Okay, you don't have to hit every point in your group. Okay, in fact, you don't have to hit any of them. There will be situations where you might not hit any of them, but you're just following the pattern. So I think we can agree that does not follow the pattern of the points, nor does that. But if I do, something like about there, that follows the pattern of the points pretty good. Okay. Now, that brings up an important issue. This video is extra long, I know. This is the beginning of chapter 1, and chapter 1 is all about linear functions, or in other words, straight line. In chapter 2, we go into quadratics, where the pattern of the points is not a straight line pattern, but the points, might be that pattern. We're like, oh, I need to draw a quadratic function that best represents it, because a straight line function isn't going to follow the pattern very well. And then in chapter 3, we'll see a new pattern of 4, chapter 4, and chapter 5. So there's 5 different patterns in this class, and they're very common major patterns. Okay. All right. So we've got our trend line. Okay. And so let's see what else we got going on here on this problem. So that's part C. Part D. Choose 2 representative points from your trend line and find the slope. And explain the meaning of the slope in context. Okay, some people, they like to skip over the explain the meaning. And I'm like, well, that's kind of really important because it means you actually know what's going on. All righty, so choose 2 representative points from your trend line. Now notice, it doesn't say, and here's another common mistake people will make. It doesn't say choose 2 points from here. It doesn't say that. It doesn't say choose 2 points from your table. It says choose them from the trend line. Okay, which means we got to pick a couple of points that are from the trend line. Now, clearly, our trend line goes through some of these points over here. So you could pick, a point or 2 from over here where the line actually hits it. Like it looks like the line pretty much goes through that point, and any of these 4 right here. So you can do that, but to help you to understand, what's going on here a little better, I'm going to do this a little differently. Okay. So I'm going to say, all right, well, I'm going to say, all right, for my trend line, when I'm going to try and go straight up, when the diameter is 9 centimeters, I'm going to try and go exactly straight over, nice and horizontal. What is my volume? Well, it looks like it's about 250. Okay. So then I would say, all right, well, it looks like we've got 9 centimeters, or when we have 9 centimeter diameter, we have 250 cubic meter volume. Okay. Let's see, what else have we got here? Let's do another one. How, because we need 2 points. How about, no, I'll go 12, I guess. Just because I feel like it, and there's nothing magical about 12. All right, I'm going to go straight up, and then I'm going to go straight over. So it's horizontal. And let's see. So that looks like 12 centimeter diameter corresponds to, that's about 2/3 of the way up from 400 to 500. So I'll say 467 cubic meters. Okay. All righty. So we got that. And now what? I don't remember. Let's see. Choose 2 representative points. And find their slope. Explain the meaning of the slope in context. Okay, got it. All right. So now I'm going to, just like I did back here with the slope, I'm going to do that for these 2 right here. Okay. Now, we would expect the slope that we get from these 2 to be close to the slope we got before. I would not expect it to be exact. If it's exactly the same thing, then it's like, that's kind of fishy because there's a lot of variation in, diameter, volume, and all that. All right, so let's do it. So the slope for these two guys is going to be the difference of their y values, their volumes, divided by the difference of their x values, in this case, their diameters. Okay, so I'm gonna plug that into my calculator, 467. Whoops, it helps if I type the right thing, I suppose. And then I want to make that a decimal. Okay, and so that's going to be 72.3. Wow, that's not as close as I had hoped. Oh well. I'm doing the best I can. And okay, so 72.3, that'll be the slope for these two guys, but I need to explain it in context. Well, I did that before when I did slope. It's 72.3 cubic meters of volume for every 1 centimeter increase of diameter. All righty, cool. So why is there so much variation between, let me change my color. That's fun. Why is there so much variation between these two numbers? Because they're both giving me slope. Well, one reason is because the first slope we found was between the lowest and the smallest points. And whereas the second slope we found was following the trend line, which is not exactly the same thing. Okay, that's one reason. Another reason is I'm drawing all of this by hand and I'm not drawing perfectly well. Okay, which you're going to do, and that's okay. Another reason is that there is, the amount of volume you get in a tree is not completely dependent on the diameter of the base. Okay, there's more to it than that. The diameter is a really good indicator, but it's not a perfect indicator. There's all kinds of other factors that include weather, salinity of the soil, and lots of things. So like I said before, I didn't expect these two guys to be identical. If they were, I would have been very suspicious of what was going on. All right. This problem is almost done. Let's see, part E, use your trend line to estimate the volume of a 13 centimeter diameter tree. Okay, wonder what that happened. Okay, so now I'm gonna do the same thing again, like I did with those straight lines. And I'm gonna say, let me choose it. Okay, so I'm gonna say, all right, well, when we're at 13 centimeters, I'm trying to go straight up and down, not leaning. What is my volume? Okay. Well, that goes off. That goes off a little bit there. So I'm going to need to extend this guy just a little bit. And let's see. If this is 100 right here, then this is probably about, I don't know, 533, about a third of the way up to 600. So I'm going to say 533 cubic meters of tree. Yeah. 533 cubic meters. And that would be it. And that's how I would go through this problem and pretty much all of